Thank you, Roger, for welcoming me. And thank you, everybody, for coming over. It's my privilege to be here. I'm really glad to see all of you. And as Roger said, it's fantastic that you took some of your time and came over to discuss and listen to some of the interesting themes around blockchain and AI. And as Roger said, my name is Roman Vaculin. I have been with IBM for several years now. I work on blockchain solutions, and my group focuses on that primarily. We are sort of in between research and development, right? So it's sort of like one hat I'm wearing is research, right? So really looking at the innovative ideas, directions. But the other leg is very, very pragmatic, very practical, right? So looking at solutions in different industries, like financial services, for example, right? Or supply chain, you name it, right? And the research is fairly applied typically, and we really see many interesting challenges and areas where we need to focus more on the research side. But I would be very interested to hear from you, obviously, what you are seeing as interesting challenges in your areas. So the theme of this conference is blockchain and AI, and it would be strange if I speak about something different, right? So the topic will be really focused at the intersection, right? I will clearly speak a little bit about blockchain separately, just to give you a very short introduction. I'm assuming that you have heard something about that. I will talk very little briefly about the AI, but primarily I'll focus on what are kind of like interesting challenges, directions, or opportunities at the intersection, right? So with that in mind, you've probably heard about blockchain hype, right? I would ask you, who has heard anything about blockchain? Okay, who is invested in cryptocurrencies? Okay, fantastic. So that's clearly one area of the hype. Right? So cryptocurrencies is really, whether you like it or not, whether you believe in it or not, it's here, right? It's happening. So it's wild. It's pretty wild, right? Many people are skeptics. Many people are very focused on that. But then beyond that, you may be surprised that blockchain is one of the top skills in the job market these days, right? Just happens to be, whether you're in the city or in Silicon Valley, it doesn't really matter. Also, in terms of investment, again, I mean, you may be debating where are we on the hype curve, right? Whether we are sort of at the top or whether we are a little bit behind the peak, it doesn't really matter, really. The point is there is quite a bit of investment happening. There's quite a bit of promise, maybe sometimes way too much, right? And we can, again, discuss about that. But the reality is that the blockchain technology is here. It's happening today, whether you like it or not. Some of the use cases may be, unexpected, like I picked one, like inside the Jordan refugee camp, that runs on blockchain. But there are many that are very pragmatic, very practical in the financial services, in supply chains, etc. I'll mention just a few of them. So what is blockchain, right? This is from one of the key people, a short definition. Blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions, but virtually everything. So it's not only Bitcoin, not only cryptocurrencies, but it could be any kind of asset, right? It could be packages, it could be digital mortgages representation of that, right? Any kind of document can be potentially represented on blockchain. That's kind of like a short definition. Here is a little bit longer, slightly more refined. I will highlight a few aspects here. One is that the previous one didn't mention, which mentions that blockchain is a mechanism to bring everyone to the highest degree of accountability. Right? So accountability is interesting, right? It's a really very highly relevant term in the business sense, where no more mistransactions will be happening, human and machines errors, and even exchanges will not be happening without consent, right? So the notion of consent or agreement is key, right? So that you will hear in different contexts, but that's an important aspect of blockchain. I will get to it in a second. And here the most critical, according to Ian Khan, is the area where blockchain helps to guarantee the validity of the transactions, right? So if I am going to send somebody $100 and we achieve the consent, right, then the transaction will be valid. It will be immutable, right? So it's one there. You can obviously update that, but the record is going to be there on the blockchain. So moving to AI, and I will not speak much about AI, there are many, many definitions, and we have all obviously heard about AI, or users of AI, or developers of AI systems, right? One way or the other. This is a definition from one of the founders, John McCarthy, right? He was a legendary computer scientist at Stanford, and he says that blockchain is the science and engineering discipline of making intelligent machines, especially intelligent computer programs. And again, obviously, it stretches hardware, software, services. You would see it everywhere these days. But the important aspect is that making the machines intelligent, right? So that's the aspect. And obviously, it's a moving target, right? What was considered AI like 20 years ago became part of traditional computer science these days. These days we are looking at areas like deep learning, etc., right? So we can obviously have many other definitions as well. I just wanted to sort of level set quickly. Now, in terms of blockchain, obviously we have all heard about Bitcoin, right? So that's sort of like the most known example. And, again, whether we like it or not, and ignoring the value of Bitcoin and the other cryptocurrencies, by pretty much every measure, it's by far the most successful instance of blockchain, right? In terms of number of peers, number of participants, number of transactions, right? So that's the most known example. And there are obviously many other cryptocurrencies. But then, you probably don't want to run your business on Bitcoin. It has issues, right? And I'll just mention a few of them. So many people have stepped back and realized, the mechanisms behind Bitcoin actually are pretty universal, right? So you may not need to necessarily, exchange cryptocurrencies. You may exchange other assets or transact with other assets. And the mechanisms, of recording the transactions in a distributed way, right, with some properties like immutability and getting consensus, is pretty useful in a universal sense, right? It's not just for cryptocurrencies. So businesses, just like us, like IBM and many others, are looking at, I would say, the blockchains for businesses rather than Bitcoins, right, and cryptocurrencies. And there's subtle differences, but important differences. Typically, Bitcoin, you can think about, like a public blockchain where, the participants can be anonymous, etc. That's not ideal for business, right? You probably want to transact with somebody who you know who that person is or that enterprise is, right? So in the case of businesses, identity is typically more important than anonymity, right? So I want to know who participants are. Sometimes I want to also control, right, who can participate in my network in blockchain. Similarly, you have heard about issues probably, like energy efficiency or inefficiency of Bitcoins, right? Because of the proof of work, which is obviously a headache. I mean, it is a great mechanism on the one hand, but it's a headache at the same time because, it consumes really huge amounts of energy and the transaction throughput is extremely low, right? In the case of Bitcoin and the cryptocurrencies network. So in the business networks and business blockchains, typically you don't have to do this sort of endorsement policy. There are different mechanisms that don't suffer with these shortcomings, much less power hungry, and are much more power efficient and allow you to do transactions with a far higher throughput, right? So that's another important thing. And then obviously, other than cryptocurrencies, you can record any kind of asset in general, just like in databases, like you can record anything, right? You can record information about people, you can record information about money, about transactions of any kind. So having said that, you may ask yourself, what is the big deal and what is the new thing about blockchain compared to business as usual, right? I mean, we see business networks like the one here on the left-hand side, right? That's nothing new per se, right? So banks transact with each other using SWIFT, for example, or companies in supply chains transact with each other in networks using EDI standards, right? So that's happening today. But typically the way how it's happening is either, if I take these different participants, which are just simple examples, typically it's happening on a one-to-one basis, right? So I send a shipment to somebody else, and maybe I send electronic record with it to somebody else, right? So it's a one-to-one. That's why you see these orange connections, which basically indicate that one-to-one relationship nature. Sometimes you would have clearinghouses in between, like a centralized entity, like central banks, for example, or you would see, in the case of stock exchanges, you would see clearinghouses in the middle, right, which are sort of like a centralized point where the transactions are happening. And obviously one issue of that is that while these systems generally tend to work, obviously we know I can swipe my Visa credit card and it works, right? I mean, there's nothing wrong with it. What happens is that typically there is fairly, like limited visibility across the entire system. So if I send a package, right, I would be able to trace it one by one if I work with one company, like let's say FedEx, UPS, or USPS, it doesn't matter. But the other companies don't have a good visibility of what is happening. Things get lost. If you ship a big container and it gets stuck somewhere in the port, again, there may be individual participants that will have localized visibility of what is happening, but getting a broader visibility is not easy to achieve today because of that siloed representation of information on a one-to-one basis, right? Similarly, things can be misrepresented. Like, so I think that maybe a shipment is stuck in one place, other company thinks because their database shows something else, like that it's somewhere else. So blockchain, what it does, it basically takes the same set of participants, party A, party B, bank, and auditor, for example, and instead of having these one-to-one relationships, it basically either supplements it or substitutes it with a notion of a shared distributed database or ledger, right? That's what you have heard about. And on top of it, it basically says, okay, now if party A sends a transaction or records it on its instance of the distributed database of the ledger, then everybody in the network will see the copy of the transaction, of that information, exactly the same. Obviously, you may think about, okay, do I want everybody to really see that? Right, so you may need some form of access control, some form of privacy, preservation techniques, but that's coming in these enterprise blockchains as a built-in mechanism. And importantly, there's a few things that are mentioned at the bottom. I mentioned shared ledger already. I mentioned privacy. That's an important aspect in that shared ledger, right? So I need to still make sure that, that everybody is comfortable with what and how is being shared with other participants. I need to have a mechanism for achieving consensus, right? So if I send you $100, the consensus mechanisms make sure that everybody essentially agrees that I have that money available, that I cannot double spend that money, right? That when the money is recorded on the ledger, that everybody is comfortable with it and everybody approves it, basically. Right? So that's a consensus mechanism. And then smart contracts, you may have heard about that. It's basically a piece of business logic that gets executed together with the transaction. Right? So say that I send the money, and maybe a business logic says that before I send it, that business logic needs to check that I have enough money, right? That I'm allowed to send it, and that the recipient maybe is a legitimate company. Right? So you can think of smart contracts as the piece of logic that gets executed. So that's sort of 101 on the business blockchains. Now, obviously, back to the hype, right? So hype is one thing, but then there is reality, right? So the blockchain is real, it's here to stay, right? And this is just few examples, right? So IBM clearly is one of the companies, but we believe, and not only we, but other companies like Juniper and HFS Research believe that we are one of the leaders in the field. We are strongly advocating for open source based approach. Right? So if I want multiple participants to work together, this cannot be something controlled by one company. It cannot be controlled by IBM. Right? It cannot be controlled by anybody else. So that's why we are strongly arguing that the platform needs to be built in open source. So we are working with, we and many other, like 500 developers across many companies, work with Linux Foundation on an open project called Hyperledger, which again, is broadly believed as the leading blockchain set of platforms for enterprises, right? But that's still sort of like, okay, so we have platform, but then many people are asking, are there any, other than Bitcoin and others, are there any real blockchain-based network? And indeed there are. So at the top, we are showing that there's at least 35 active business networks. I mentioned few of them. TradeLens, for example, focuses on shipment of big containers, right? So majority of the global trade happens through these containers, right? So there is with many participants, there is a blockchain-based solution with Maersk and others focused on shipping of containers and the documents, digital documents associated with that. There's another one focused on trust of food. So again, supply chain-based solution. You've all heard about things like food poisoning, salmonella and other. Recently, there was a lettuce issue right here in the US. The problem is that today, identifying where maybe the food poisoning or spoilage is coming from, it's very complicated because it's a complex ecosystem, right? So if I am a retailer and I sold a lettuce, somebody gets sick, it takes quite a while to figure out where does that contamination come from because of the lack of visibility. And there are many other examples, right? And importantly, we are pushing a lot on the innovation aspects. And that will take me to the blockchain and AI, but I just want to mention a few, right? So we are pushing a lot of effort into innovating and patenting with a high focus on blockchain. Many researchers are working on performance, scalability, etc. We work on integration between IoT and blockchains, but that's not what I will want to talk about. But importantly, we are looking at the AI and blockchain, which is really mostly thinking about how can you infuse more trust either into AI or how can you take advantage of AI in the context of blockchains. So with that in mind, basically what I will do, I will take a look at two sides of the coin, right? So we take blockchain and think about how can AI be used in the context of blockchains, solutions, etc., right? Are there any areas where this could be very meaningful and helpful? So that's one side of the coin. The other side of the coin is blockchain for trusted AI. What can blockchain do for AI, in other words, right? So that's a different side of the coin. Also, we believe highly interesting, very exciting area. So let's start with the first one briefly. So there are a few examples of what AI can do for blockchain. So think of blockchain very initially as essentially a very clever, trusted, distributed database, right? Where you're collecting many, many transactions. Think about it like that you can have millions and millions of transactions. Interesting thing is that these are transactions from multiple participants, right? So it's not just my little MySQL database. It's from many participants potentially with privacy and access control applied to it. But the important aspect is that everybody basically agrees on these transactions, right? So you have effectively trusted transactions. So the natural question is, how can you unlock the value of these transactions, right? So that's a very natural first step. So after I'm recording transactions, what are these transactions telling me? What are the patterns? What can I learn? And that's very exciting because so far most of the optimization, if you think about businesses, is happening within the businesses inside, right? So we've been optimizing all sorts of things, business processes inside the businesses, right? But across businesses, that's an area where we see a lot of future efficiencies that can happen. So this is where the analytics and AI applied to blockchains can be very helpful. And we have few first instances. Here on the right-hand side, you can see a dashboard that's running on top of blockchain solutions in a privacy and secure way, right? So that's one example. The other one is if you're a data scientist, you would want to perhaps use your favorite data science tool in connection with blockchain, again, in a way that securely connects to blockchain and maintains the same data protections and privacy guarantees, just like blockchain does, right? Now, as I mentioned, the areas of opportunities here are basically techniques of analytics that are privacy preserving, right? So if I am submitting some transactions, let's say I'm a manufacturer, right? And let's say I'm submitting my transactions to blockchains that potentially everybody can see, that's a good thing and the bad thing at the same time, right? Because it can help optimize, but it can also potentially reveal issues or problems with my business to everybody else. So that's why the privacy is very important because you may want to only selectively reveal certain things. And similarly, the analytics could be very interesting, but you want to do it in a privacy-preserving manner so that you don't disclose any information that you don't want to disclose. And same thing, you may even do it unintentionally, right? So there's these concepts of privacy that are very interesting, go beyond just access control. All right, so that's one side of the coin. The other side of the coin is blockchain for trusted AI, and this is sort of flipping it and says, okay, what can blockchain do for AI? Say that you have machine learning techniques, you have algorithms that are doing data pre-processing, that are doing training, and eventually maybe are involved in important decisions. Things like, can I get a credit at the bank, right? What is my credit score? Can I get a mortgage? Or, do I get a job? Right? So you may have heard yesterday that Amazon have shut down apparently a machine learning based approach that was deciding about who to give a job versus who not, because there was a bias in it apparently. Right? So it was apparently disqualifying based on gender. And so this is so you see that AI techniques are becoming much more prevalent today. You see it everywhere, and we will see that even more. But then obviously there are questions, right? There are questions and issues. Do we trust AI, right? Can it be trusted, etc. Right? So blockchain can help, we believe, with improving certain aspects of AI. It's not a silver bullet, right? There's a lot of research focused on trusted AI in general, but blockchain could be one of the aspects of it. So imagine a scenario where every piece of information and every operation that happens along the AI process can be recorded on blockchain. Obviously, that's a little bit wild, right? Because maybe you want to do it very carefully. Maybe it's not every step. Maybe you want to do it in a privacy-preserving way. So there are all sorts of issues along the way. But it would allow you, hypothetically, to say, okay, if I have a bias at the end because I get maybe dinged for some reason, I may be able to go back and see why did that happen, right? Because I can understand by using the audit trail what was happening. Similarly, so that's the traceability, assurance, potentially fairness. Potentially you can use it for measure and regulate and control quality, right? And the scenarios where blockchain could be helpful, I just listed few. One is very naturally in the case where you are dealing with any kind of natural distribution, right? So multiple companies participating in the AI process. So think about an example where, like two banks are doing maybe some form of training together collaboratively, or maybe some party provides data, another party trains based on the data, and yet another party maybe uses the trained model to do something with it, right? So those are very natural examples where you have distribution and therefore potential for lack of transparency and therefore some need to improve it, right? Other examples include like complex long-running processes, right? So there's some, as you know, like that machine learning training takes a long time typically, right? So you may need to run long-running training. It can take days and weeks. Now the question is, what if something happens in the middle, right? Did everybody do the right thing? Was everything done correctly? So I will just show you a simple example. It's called Fusion AI, just the demonstration that we have developed. So think of this scenario where you have two different banks, right? Let's say that these two different banks want to do, I don't know, maybe credit scoring or anything, right? So say that I have payments locally for one bank located in Europe. I have similar transactions for a bank located in the US. Maybe it could be different banks. Maybe it could be two branches of the same bank, right? For different reasons, you may not be allowed to send the data over, right? Like GDPR being one or other regulations, right? So what you can do, you can train locally, right? The one bank can train the model locally, the other bank can train their model also locally. Then you can have something that we call Fusion Manager, like either a third party or a third component that instead of taking the data, takes the models, right? So it takes the trained model from one side and the trained model from the other side, does some math in between, some fusion, and then it says, okay, I have put things together, hopefully it's better than the two inputs, and then it sends it back to the originals, right, to the original participants. And then the original participants say, okay, fine, let me improve, right? Let me retrain. So they, again, take the fused model, retrain locally, and then it goes on and on. So you do that training of the models in a localized way, which can be completely privacy preserving. You don't have to move data around at all, right? So you save, like by simply not having to move data around, and that's great. And it turns out that this approach actually works reasonably well. So if I look at this graph that shows accuracy over the number of iterations, I said that these guys can iterate basically, right? So to improve over time, you would see in the dark blue and dark green accuracy of the models, assuming that you do everything locally only, right? Only local, using your local data set, that you don't have anything, you don't know anything about the other participant. And these lighter blue and green show you how does the accuracy improve if we allow that fusion manager to fuse the models, right? So basically you have some information that's been used in the fusion manager. And the red line shows you what is the best possible approach if you would allow everybody to merge the data sets, right? So if I take both data sets together, put it into one data center. So you see that basically that fusion allows us to get pretty close to the ideal scenario without having to move data around, right? So that's actually very nice. Now, how does blockchain play in this? You may ask me. So the problem is that each of these participants may cheat potentially, right? You don't know whether they are sending you the right model or whether they did the right thing or no. So instead of fully trusting everybody, we say, all these participants, bank 1, bank 2, and the fusion manager, along the way, can basically record fingerprints of the data and the steps that they perform on blockchain, right? So instead of just blindly trusting everybody, I would record, this is what I have done, right? This is what I have done in my iteration. This is, like the digital signature and the fingerprint of my model that I have produced, and you go on like that. So what you get is something like this. This is a little bit hard to read, but basically what it shows you on the left-hand side is a representation of the blockchain transactions for that first bank, on the right-hand side for the other bank, and in the middle are the transactions of the fusion manager. And over time, you would basically see representation of the individual transactions. So for example, here on the right-hand side, I see that the second bank in the blue box performed a training operation on its own data, right? And then it produced the model over here, the green model. Same thing was happening on the other side using the other data set. Then they provided these trained models to the fusion manager. The fusion manager fused it. That's the blue operation in the middle. And then it produced a fused model, right? By the way, the blockchain doesn't record the actual data, right? So again, that may be an issue. We are only using the hashes of the data or fingerprints of the data, right? So it's perfectly safe. But now if, let's say, the auditor comes later and says, oh, I don't believe that this guy did the right thing. I think that they may have cheated, right? At any point, the auditor can validate that everything was actually okay, right? That every step was okay because you know what was the input and output, etc. Right? So this sort of gives you an example of very practical, this is an implemented system, right? We have it running, and it works pretty well. So with that in mind, we are getting to the conclusions of this short talk. So I promised you to highlight few challenges, right? So these were and opportunities, obviously. So again, this has two sides, right? Two angles. So blockchain, on the one hand, enables the next generation of transactional systems on a high level. You can think of it this way, right? So instead of having databases, in many or in some cases, blockchains could provide you that next generation of the systems. And it opens up new opportunities in terms of cross-organization efficiencies, right? So instead of optimizing locally, now I can potentially optimize across the entire supply chain or across multiple banking participants, right? So that's one great angle. And obviously AI will play a big role in that space. We expect that these can be transformational, not in the sense that Bitcoin promises the central banks are going to disappear. We don't expect anything like that. But the efficiencies can potentially be transformational. right? So it can really help to dramatically speed up the processes, lead to savings, etc. The challenge is there, obviously, as you probably know already, and is scaling, right? So if we think about, let's say, food supply chain, it's a gigantic, massive supply chain with millions of participants, right? So that's one angle. We are working on that actively. We are making very good progress, but that still is a great area of technical opportunities and research. Privacy, I mentioned that a few times. We're making really great progress, and not just IBM. Many participants are looking aggressively at privacy and security, right? So everybody says blockchain is the most secure database, which is certainly partially true, but you've heard about hacks, right? Like people suddenly like some number of bitcoins disappear. So clearly security is a big area of focus. And from the AI standpoint, we are looking at, as I mentioned, like the trust in AI and the trusted AI is really something where you will see a lot of focus from many companies, right? Because as I mentioned, like AI will influence every single aspect of our lives, whether it's in the medicine, right? It will make key or help making key decisions, or financial services, or anywhere, right? Or consumer space. And with that in mind, you want to be sure that you know what is happening and why is it happening, and that you can trust the AI systems, right? So that's really, really going to be critical and is becoming very important. The big opportunity and big theme is democratization of AI, right? So these days, AI is largely a function of who owns the data. And without naming companies, we know that there's a strong centralization, right? There's owners of data on the internet is very strongly centralized, right? And that's why, few players are going to take the largest benefit, right, of AI. What blockchain promises is huge decentralization, right, where many players can take advantage. Obviously, opportunities and challenges are warranted, fully privacy preserving and accountability of AI. And I believe that we will likely see the next generation of both the AI systems and the transactional systems that will leverage blockchain and AI together. So I'm going to pause here at this point. Thank you very much. And if you have any questions, I think we have a few minutes for questions.
All right, let's give a round of applause. Thank you so much. So we are going to have a couple of microphones coming down the aisles. Should you want to ask a question, this is the time. We have a few minutes for Q&A. But if you're in the middle and you have a question, just raise your hand, then I will repeat it.
And I'm going to be around today,
and,
right?
And Roman will be around as well.
So I'll be more than happy to obviously talk with each of you, right? So
during the breaks, lunch, and we'll have plenty of opportunities. But in the meantime, any questions right now? Thoughts, comments? Yes, sir?
Microphone is coming. Oh, okay. Just a second.
They'll try to get one to you there.
I just wanted to, hi, it's Steve Globus. I just wanted to ask a hypothetical. Two major banks in Japan, international banks, and they're entering transactions in blockchain. Do they do that in English or is that in Japanese? The actual language, the entering of the, not the numbers, but the data that's interpreted.
So I think it's a very good point, right? I think, first of all, just like a database, blockchain does not necessarily provide you an answer to that, right? So just like you would have a question about, if I'm transacting with you and you have your bank, I have my own bank, and we are recording in the database, right? That does not prescribe how is it going to be, how the data will be represented, whether it's in English or Japanese. So blockchain alone does not give you an answer to that, but you are touching a really interesting and important point, which is standardization, right? So blockchain effectively, what it does as a side effect, right? And it turns out to be one of the most significant side effects, is that it forces standardization, right? So we have seen that in supply chain, in these examples, like that shipping of containers, whether you're looking at shipping companies or, like suppliers, internally, everybody represents data in different way. And that obviously is a problem, right? But what these blockchain solutions do is that they enforce standardization, leveraging existing standards like EDI, GS1 in the supply chain cases, or SWIFT standards in the financial services spaces. But beyond that, also it pushes the envelope to the next generation of standardization. Right? So I think that that's really, really important aspect of blockchains.
So the aeronautics industry, airplane, it's
Right.
all English.
Okay.
So when an Air France, domestic Air France lands in Charles de Gaulle, the pilot is talking to the tower in English.
Correct.
So are you going to see that kind of standardization in blockchain? Or
I suspect so.
You
I
suspect
suspect
so.
so.
Thank you so much.
Yes, I think so.
Awesome. Yes, over there on the left, or my left.
Thanks. That was a very interesting talk. I had a question about the Fusion AI platform that you mentioned.
Okay.
That sounds really interesting. If the models are being, in your example, if the models are being trained locally, and then you're submitting the model to this third party in the center, what is that third party using to improve the models? Because the data isn't being shared with the third party, right? So what's the training set or the benchmark set being used to improve create the Fuse model?
So that's a fantastic question. Thank you for asking it. So if you think about it, right, the most naive approach, right, and that's really the most naive approach. You take these models, right, say that it's a neural network, right, and you basically can take an average, right. So sort of say I'm learning. Let's say I'm classifying dogs and cats, right? Like let's say I have examples of dogs and you have examples of cats, right? So you sort of say, okay, one area of my neural network may be very good at representing cats, but it has never seen a dog, right? So what it can do, it basically can do an overlap and some form of merge. And the operations can vary. It could be average in the most simplistic naive case, doesn't work very well, right? But then there are many better operations. I will not go into detail. We can discuss about that, right? But you can do a lot of stuff without taking the data as such, and simply by being clever about merging of these models, right? And it works actually really well, and it's pretty generic known technique.
All right, do we have another question? One more. Yes, in the back. Can someone get him a mic?
I was wondering if you could expand on this last notion of trusted AI platforms embracing blockchain. If you're thinking more in this Fusion example, or you're thinking that certain artifacts of training or using a given model would be posted as a trust enabling activity.
So that's a really good question. Again, I mean, in this case, what I meant is a slightly broader perspective, right? So that example of that Fusion AI was effectively using blockchain to simply record for the audit purposes, right? Think of it this way, right? And validation, you can validate after the fact. But then, broadly speaking, right, this is sort of one angle, right? If you push the envelope farther, there is work happening in the context of secure multi-party computation, right? So that you can basically have multiple parties compute some part of the process in such a way that you can trust it by nature of the computation. That you don't have to validate after the fact, right? So again, the most simple example is that you do it in a trusted environment, right? So say that I deploy to you a server with a secure environment that I fully control, right? So whatever you dump into it, I know that it cannot be modified. That's the most, again, simplistic way of thinking about it. But there are ways that are purely software-based, looked at the secure multi-party computation, that as part of the computation, you provide an evidence of that your computation is done correctly. Right? So that's another step, sort of, right? So auditing is one, then the trusted computation is another one, and then you can sort of think about it more broadly, right?
All right, we are
Excellent.
out of time for Q&A, but like Roman said, he will be around throughout the day, so please do engage him, find them during lunch, and you can connect with him again.
Thank you so much.
Let's give him
Thank
another
you.
round of applause.
Thank you.